Alright, and here we are in RC low pass filters. And just like the other ones, we're going to talk first about how to identify your filter. So this one we use high C and low C to identify our filters. You'll notice that the capacitor is in parallel with the output, and physically that actually places it at a position that is lower than the resistor, at least in these circuits. And these are all the ones you're going to see on your exams. So it works to remember the high C, low C, mnemonic to remember your RC high pass filters from your RC low pass filter. So in this, it is a low C, a low capacitor. So it is a low pass filter. Okay, the rest of it is very similar when you look at the frequency cutoff and the half power point. The only big difference here, besides identifying the filter, is the formula. So the frequency cutoff is a different formula this time. And it is 1 over 2 pi RC. And again, when you're doing this formula, you need to do everything that's in the bottom first, and then take 1 over that. Or you can do the x minus 1, which is the same as doing 1 over the answer on your calculator. All right, and you'll notice we just threw in the numbers for our circuit for both resistance and capacitance into our formula, and we get 10.62 kHz as the frequency cutoff. And again, these circuits are identified by what they do. This is a low pass filter, so it is going to pass pass a effective voltage when it is 10.62 kHz and below frequency-wise. Anything above 10.62 kHz is going to give you an ineffective voltage at the output. So this is a functioning or effective filter when it is at 10.62 kHz for incoming frequency or below that. Okay, half power point is exactly the same as the other ones we've done. Of course, it does deal with voltage, but all you do is take incoming voltage, multiply it by 70.7% or 0.707, whichever you like, and you get, in this case, 16.97 volts. And that is the start of effective voltage. So as frequency goes down, that voltage will go up at the output. And as frequency goes up, that voltage will go down. And once you go below 16.97 volts, you no longer have an effective filter because the voltage output is not effective anymore. It is below that threshold. All right, and that's it for RC low pass filters. We're going to roll right into high pass filters, actually. So here's our high pass filter, and since we just talked about how to identify it, it's no surprise that our capacitor is high. Now it's at the top. It's in series with the output, which makes it a high pass filter. Remember, high C, low C. Okay, frequency cutoff uses exactly the same formula as your RC low pass filter. So it's that new 1 over 2 pi RC. You're going to throw in your numbers there. And for this one, we get a frequency cutoff of 3.18 kHz. Well, this is a high pass filter, so it passes high. So that means you are going to have an effective voltage at the output at 3.18 kHz and above. And you will have an ineffective voltage at the output below 3.18 kHz incoming frequency. Half power point, exactly the same formula as the previous ones. And so I'm just going to throw it up there real quick. We end up for this one with a voltage of 28.28 volts. Now that's the starting point. That's that cutoff point. So anything above that. So 28.28 volts and above is all effective. Below 28.28 volts is an ineffective filter. And you get that, of course, in this particular circuit. You get those voltages above going above 3.18K, and you get those voltages below by going below 3.18K. All right. And we're going to do one more video where we look at the arrows for both RC and RL circuits. But this is it for the calculations on your RC low and high pass filters.